Hey developers, Marco Arruda here. This is the second chapter of the series exploring ROS2 with a wheeled robot. In this chapter I'm going to show how to subscribe to the laser scan topic of the robot we set up in the previous chapter. So let's do it. As usual, we're going to use ROS2. In this case, I have already created a project specific for this chapter, okay, but we're going to start from the same point we have stopped in the previous video. So at this moment, the only thing that I have in my project here is the simulation set up and working. And we are going to create from the scratch a new node, which is going to be the laser scanner subscriber. So let's start opening the editor and check what we already have there. I'm going to also leave a web shell already running. Okay, great. So we have the ROS2 workspace. Go to the source folder and you can check there we have the my package created. Source folder is still empty, but we have a single launch file created, which is the dolly launch Python file. In this case is the one that we have been using to start the simulation. So let's start from this point. For example, I'm going to source the ROS2 workspace. So remember, differently from the ROS1, you have to do source ROS2 install setup.bash file. We're gonna have this message. It's fine, it's okay. It's telling us that we are changing from ROS2, which is ROS1, to ROS2, which is the latest version. In this case, ROS Foxy. Okay, great. Then I'm ready to launch. So let's do it like this: ROS2 Launch. Then the name of the package, my package in this case. And the only launch file we have there is dolly launch.py. Press enter. I'm gonna open Gazebo. Let's leave it here on the bottom, at the bottom on the left side, so we can check our simulation if it's running or not. And just before we start coding, let's check the topics that we have available in the robot. So in this case, open a second tab in the web shell. Don't forget to source again the ROS2 workspace. So ROS2 workspace install folder setup.bash. Then ROS2 topic list. There it is. So this is the topic we want to subscribe in this case. /dolly/laser_scan. And we can do a quick test here. For example, ROS2 topic echo. Let's check the messages if they are coming, for example. Okay, great. Everything seems to be set up and working fine. So let's start coding. We're going to use C++ in order to go through how this series. I think it's more interesting that we go in a different language. Since we are already working a little bit with Python for the launch files. So let's go with C++ for the files you're gonna code. So in this case, I'm gonna create inside the source folder my first node. I'm gonna call it reading laser C++. There it is. We have just an empty file, and this is how it has to go. So I'm gonna start including some libraries here, and the first one is the ROS default library for C++. So I think it's something like ROS core libraries or similar, which is more or less the same that we had in ROS1 for the ROS cpp.h file we used to include. Okay, next library we're going to use is the sensor messages laser scan. That's because this topic that we have here, so if we check again ROS topic list, and then if we check the type of the messages that are coming into this topic we're about to subscribe. So just do like this, ROS2 topic type and the name of the topic. You're gonna see that we have sensor messages, message laser scan. Then we have to use this library. In this case, the laser scan here, we have capitalized text, but in this case we have to type everything in lowercase separated by an underscore. Okay, great. So just after including the libraries we're going to use, I'm going to start this time creating a class for my node. So I'm gonna call it reading laser, which is gonna be also the name of my node. So I'm gonna create a class with the same name. So class reading laser, and extends from the core library of ROS, a class called node. Okay, I think that so far so good. This is quite simple to understand. Then in C++ we start defining our public methods and attributes inside our class. And the first thing I want to declare here, and actually it's gonna be the only public method we're gonna have, is the reading laser, which is actually the constructor of the class. So I have reading laser here, and again it is inherits the node class, and I have to pass here the first parameter, which is gonna be the name of my node. In this case, it's called reading laser. Okay. Well, now we have quite different stuff of ROS2 that we don't we work differently in ROS1. And the first thing is about the subscriber. So let's skip this line, for instance, and I'm gonna explain in a few seconds. So first thing, I am instantiating the subscription. So subscription equals to, then the node has a method, because we are inheriting node class, and we have this method here, create subscription. We have to pass the type of messages. So we have sensor messages, goes to message, and finally we reach laser scan, which is the final type of the message. And then we have some parameters. The first one is the name of the topic. In this case, we have a different name here, but we're gonna do a mapping whenever we launch this node. So let's keep it like this, for instance. So first parameter, name of the topic. Secondly, in ROS1, we used to pass this argument as the amount of message we could have in a queue of message for this topic. But in this case, in ROS2, we cannot, we have to use a kind of a pattern, the same pattern that has been used to the publisher. In this case, if we check in the Dolly robot repository, you're gonna see that they are using the queue of messages, the default queue of messages of the ROS2. So in this case, we have to instantiate this object here, which is the default key OS, and I have to pass the same variable here. Okay, ROS1, or even in ROS2, in other examples, you can find something like this, maybe 10 messages or just one message, or 0 or something differently. But in this case, if you try to use an integer right here, it's not gonna work for this robot because it's using the default QoS from ROS2. Okay, so you can see it just as a pattern or something that we just have to do in ROS2 because this was just done like this. Okay, but in the future you can go further and read about it and then understand why it has to be done like this. Okay, great. So finally, the third argument, we have to pass the callback method. In this case, we have to do this bind here because we're using a class, so it's not just a simple function. And I think it's very similar that how we have been doing in ROS1, also when you're working with classes and methods. So in this case, you have to bind the class and the method of the class, and finally pass this object, which is the reference to the object that we are working with. And in this case, finally we have an _1 here, which comes from the standard libraries of ROS, and you have to include this as well. So actually not include, you have to tell that we are using this, and in this case it goes like this. Okay, great. So now we have already our constructor defined. Then let's go for the private methods and attributes. In this case, what do we have there? So I'm going to start private, defining the topic callback, and it goes like this. So this is it's a void function, and it goes like this, topic callback, because it's the one that I'm referencing in the subscription. And the only parameter that we have here, we have to define also the type, which is the laser scan. So it goes very similar to the type of message we pass in the subscription. sensor messages, message laser scan, but just after that you have also to use the share pointer because we're working with C++ again, and whenever you use a pointer we have to define explicitly how this is a pointer. So it goes like this, shared pointer, and the variable that contains the pointer, which is underscore message. And the only thing I'm gonna do here is to print the messages, okay? So we're not doing anything useful yet for the robot using this message. So just doing this ROS core libraries, ROS C++ info, and I'm gonna use my node to get the logger information, which is the first parameter. And secondly, I have the text that I want to print, so I heard something, and I'm passing two extra parameters here, the reading at the position 0 and the reading at the position 100. So you can change these values, actually it's not important, and you can also remove these and just leave a single message here, a single parameter, a single reading inside the laser scanner. But I'm using two just for the sake of example, and then you can see that we have different readings for both positions. Okay, great. So next thing I'm going to define as private here is the subscription itself, because we have already used it in the constructor method. So as you can see here, we have subscription, so we have to define inside the private, and it goes like this. So subscription is a ROS subscription, and the type of it is again the sensor messages laser scan, and it's a shared pointer of this type of message, and the name of the variable that contains everything is subscription underscore. So it goes like this. And finally we have our class ready. It's already done. So let's start creating our int main. As usual, for when we work with the C language, we must have a int main function to start everything, and then we have argc and the values of the arguments, start the function. Then first thing we have to initialize ROS stuff. It goes like this. Then I'm gonna define my node. So I'm creating this variable node to contain the object, and it goes like this. So this is the type of the object we are instantiating. Then I'm gonna put a log here so we can see whenever the program starts. Okay, so I have just a nice message here for to say hello to my friends. Then you remember that we used to have the ROS spin in ROS1. So whenever we're working with subscribers, I like to classify it like a passive node, because the node itself is not processing anything, it's not doing anything except for receiving messages and showing them. So the only place that we are really working here inside this node is inside the callback. So we must have this spin here, which is something that is gonna hang the process and say, hey, stay here and wait for messages coming. So this is how it's done in ROS2. Okay, so we don't have ROS spin, just we had in the past ROS1, but we have to pass the node as an argument. That's why I'm creating a variable here for node. You could also get everything here and put inside this method and just remove this variable, but I like to do it like this because it's more clear for me, and I think also for everybody to understand what is happening here. Finally, if something happens and the spin method ends, then we have to do a ROS shutdown in order to finish everything, close connections and finish processes, internal process of ROS. And finally, we have to return 0 because of well, the standards of C++ development. Okay, great. So right now at this moment, we must have everything ready for compiling. So let's try it. I have already sourced the ROS2 workspace, so I'm good to go to compile, and I'm gonna use the command again, call build sync install And the only package that I want to recompile here in this case is my package. Let's see what happens. Crossing fingers. Okay, great, so we have a problem. Let's check what happened there. So first, line 24, I have an error because, okay, I may have missed something. Let's check here, private, public reading laser. I think that's not the case. Well, I wrote it wrong, so let's try the compilation again. It was a syntax error. Now we should have, okay, we have a different error. Okay, of course, I need to finish the instruction here, the definition of my class. Syntax error again. Okay, great, so everything went fine. Now let's try to run the node and see what happens. So in this case we have ROS2 run, my package, reading laser. So there it is, we have a message being shown, but we don't have any messages coming from the subscriber itself, which means that the messages are not coming, or we are subscribing to the wrong topic. And actually, that's true. Remember that we have checked here ROS2 topic list, and we have dolly/laser scan. And in this case, I am subscribing to the laser scan topic, which is quite different. So what I wanted to show here is how to map messages to the topic. Okay, so in this case, we're gonna use a launch file. Of course, I could just change the name of the topic here, but I don't want to do like this. I want to create a new launch file for us so we can practice and understand again, reinforce how launch files are created in ROS2. Okay, so let's call it reading teaser.launch.py. There it is. And just before we create this launch file, remember, this is, I think everything is new here because we have been following the two-wheeled robot with ROS1, and I want to express that we're gonna go through how many concepts of ROS2, and we have many different things that we have already noticed, things from the command line interface and also into the code. Everything is, I think it's quite different, but the architecture of ROS, I think it's very similar from ROS1 to ROS2, but yeah, the code is very, very different and many things that you have to understand and learn. So I think it's important to stress that everything that I'm showing here was taught to me before in the ROS2 basics course, okay, and you can find in the Academy. So we have a course in 5 days in the same line of the very successful courses of ROS Basics in 5 days, ROS Navigation, Perception in 5 days. Then we have this ROS2 Basics for C++, which is actually the same language you are using in this series, in 5 days. So all the concepts and everything that we are using here, you can get the concepts and have a better understanding if you follow at least this course or something similar, okay? Then, great, let's get back to the launch file. First thing for launch files in ROS2, I need to import launch commands from launch description and nodes, okay? And I need to define a function here, which is the launch description generator. So basically what I want to do here is to launch a single node. I'm calling it reading laser, and it goes like this. So this is a node type, and the first parameter is the package. The name of it is my package, and the executable is the reading laser. I want to see the logs in the screen. And the most important thing here, which is the remappings. So this is an array, and the first thing that we are mapping, the only thing actually we are mapping in this case is the laser scan. It has to listen to /dolly/laser scan. Okay, great. And finally, we must return the launch description, which contains the reading laser node. We have just defined there. Okay, great. We must be good to go. One more thing that I want to show you is that you have to change also the CMake list files, because I have changed it before, but it's important to show what I have changed in the first place. So I'm putting it to the original state, and there it is. So first thing you have to add there in your file, if you are launching your previous project, you have to do it like this. You must put here find package sensor messages, because this is the library we are including here, sensor messages. Then second thing, in order to compile the program, you have to, well, actually if you don't put anything here, everything is going to be compiled, but you won't have any executable. This is because the CMake list file is not included, is not including the executable. So you must include it like this, add executable. This is the name we want to have, so reading laser, and it points to the file we have created, so source reading laser. And finally we have to set the dependencies this executable needs. So in this case, reading laser needs not only ROS core libraries, but also standard messages and sensor messages. Okay, great. And one more thing, we're going to install not only launch files, but also this reading laser new executable. So it's going to be compiled with these dependencies, and also put available as an executable in this package. Okay, great. So let's recompile. Now I am recompiling not because of the C++ file, but because of the launch file I have just created. So in this case, I must recompile in order to generate and put this launch file as something that the ROS2 workspace should know. Okay, so let's go again to call compute and compile this package. Crossing my fingers and hope I didn't commit any syntax error again. Okay, great, there it is. And the last time we tried, we just could see the hello my friends message, and this time we expect to see a bit more. And in order to do this, let's launch ROS2 instead of run. I'm gonna use launch because I want to choose the launch file, because it's the one that is remapping the topics for us. And in this case, I have my package here, and the launch file is the reading laser launch.py. So press enter, and there it is. Great. So what we have here is a lot of tons of messages from the laser scan, and remember we are showing the positions 0 and 100. Here it is. Okay, here it is, 0 and 100. Then they are all infinite values, because there is no obstacle here in this scene. So let's put something, and okay, now I have to find the 0 position and 100 position. I have no idea where they are, so I'm just gonna put a lot of boxes around the robot and expect that we find something. Great. So I found the 100 position. Now for 0, where it is, maybe here. Okay, great. So we have some values there being reading, and if we move the robot using the simulator here, we must have some variation in the readings. Okay, great. Well, so this is it. This is the goal of this chapter here. If you like this kind of post, don't forget to leave a like, subscribe to the channel, and leave a message so we can know what you're thinking about the series, what can be improved, about your doubts, and we can help you keep following this series. And next chapter, we're gonna do something useful and move the robot finally, sending some messages to the wheels of the robot. Okay, great. So see you there. Bye.